In this video, we are going to go over some examples which hopefully will serve you well on your homework. And this is our first example. We want to graph the equation y equals negative 5 times the sine of 3x over a 2-period interval. Of course, to do that, we need to know what the period is. And we're also going to want to know what the amplitude is. Now, we have learned from our previous video that for the function a times the sine of bx, the period is always going to be equal to 2 pi divided by b. And the amplitude is always going to be equal to the absolute value of a. So in this case, b happens to be equal to 3. And our period is going to be 2 pi divided by 3. Pretty straightforward. Now, in this case, a is equal to negative 5, so our amplitude is going to be the absolute value of negative 5, which happens to be 5. Okay, and then the next thing we need to do is actually graph the equation. Well, in this course, with the software that we're using, you don't need to graph the equation, but you do need to recognize the correct graph. And we can use these tools to help us. First, the fact that we know that the period has to be equal to 2 pi over 3, and that the amplitude has to be equal to 5. Now, if you look at this graph, you can see that the period here is 6 pi squared, not 2 pi over 3. So this can't be the graph. And this graph varies between negative 1 and 1. So this can't be the graph either. So it's either going to be this graph or this graph. And we can figure that out by actually evaluating this particular function at that value right there, where it's at a peak. And what is that value? Well, this value, if this is 2 pi over 3, then this has to be 2 pi over 6, which means that this must be 2 pi divided by 12. So what we want to do is you want to evaluate this expression at that particular point. And that is going to be y is equal to negative 5 times the sine of 3 times 2 pi divided by 12. That is going to be equal to negative 5 times the sine of pi over 2. What's the sine of pi over 2? Well, that's just simply equal to 1. And negative 5 times 1 is negative 5. Now, at this particular point, the graph is positive 5. Cannot be the graph. However, at this particular point, the graph is negative 5. This is the graph that we want. Okay, so what we can do is use what we know about the period and amplitude to rule out some of the possibilities, and then just pick a point, pick a discerning point, not obviously where it crosses the x-axis, but perhaps where it should be either a max or a min, and see which one of those points actually agrees with the equation. Okay, here we want to graph y equals negative 3 times the cosine of 6 pi x over a 2-period interval. Once again, you need to figure out what the period is. Remember, the period is always going to be 2 pi over b. Of course, in this case, b is equal to 6 pi. So that is going to be 2 pi divided by 6 pi. Pi's cancel. We have 2 6, which will reduce to 1/3. Okay, so that is our period. Now, our amplitude we can get from here. Once again, our amplitude is going to be the absolute value of a, which is the absolute value of negative 3, which is 3. And with that information, we can actually figure out the graphs. So here we are. Once again, we have to choose the correct graph. What we already know is that the period has to be 1/3. This is 12 pi squared. This cannot be a graph. The amplitude has to be equal to 3. It has to vary between negative 3 and 3. This one, if this is 6, that's half of it. This varies between negative 3 and 3. This one varies between negative 3 and 3. This one does not. This one only varies between negative 1 and 1. This has the incorrect graph. This has the incorrect amplitude. Can't be the correct graph. So now we want to choose a point. For the last one, we want to choose a point which is easy to compute and is actually differentiable, or it's different between the two ones. In other words, you don't want to compute a zero crossing because that would make no sense. But computing here would make perfect sense. And of course, that is the best part because that's when x is equal to 0. All right, so there, y is going to be equal to negative 3 times the cosine of 6 pi times 0, which is just negative 3 cosine of 0. Cosine of 0 is 1, so we have negative 3. This right here is negative 3. This right here is positive 3. This cannot be the graph. Therefore, this is the graph that we're looking for. Now, for our next example, we actually want to use this graph right here to determine to find this equation. Now, the first thing you can notice is that over here, this is 0. And basically, when x is equal to 0, y is equal to a positive value. So that kind of tells me that this has to be a cosine. Okay. Also, what else do I know? I know that this graph is going to vary between negative 5 and 5. Okay, so its amplitude is going to be the absolute value of 5. And when x is equal to 0, I get a 5. And I can only do that if I multiply my cosine by a 5. Okay, so we have cosine something, and it's going to be an x here because it's some multiple in x. Okay, so basically this is b. We need to figure out what b is. Now keep in mind that our period, t, is always going to be equal to 2 pi divided by b. You can do a little algebra, and that will tell you that b will always be equal to 2 pi divided by t. What is t? Well, here is one complete revolution right there. Okay, which is what t actually is. T is basically the time for this thing to takes to repeat. That is pi over 2. So this tells me here that t is equal to pi over 2. So we can substitute that in here, and we are going to have b is equal to 2 pi divided by pi over 2. The pi's cancel. Okay, 2 divided by 1/2, it's just like 2 times 2, which is 4. Okay, so we could put that in for b, and that is our answer. We get that y is equal to 5 times the cosine of 4x. And this brings us to our last equation, or last problem, which has to deal with basically interpreting a sine function model. And this right here gives you the average temperature in Fahrenheit, degrees Fahrenheit, in Phoenix, Atlanta, and it says it can be approximated by this particular function. What does this tell you? Well, this tells you that the temperature in Phoenix can be as high, on the average, can be as high as 93 degrees. That's basically 19 plus 74, or as low as 55 degrees. Must be nice. Okay, x is the actual month, and basically x equals 1 corresponds to January. Now, according to the model, what is the average temperature during October? Well, that is when x is equal to 10. So that's going to give me 19 times the sine of pi over 6 times 10 minus 4.3 plus 74. And then for April, well, that is when x is equal to 4. And that's going to be 19 times the sine of pi over 6 times 4 minus 4.3 plus 74. And I know that many of you probably have a relatively decent idea of how to compute that on your calculator, but I'm going to do it for you. I'm going to do it again anyways, primarily because I just want to make sure that you guys are aware of some little tricks you can do if you have a TI-84. So here is my TI-84. The first thing I'm going to want to do is make sure that I am in radians. So radians. If I ever see a pi in my argument, chances are pretty good I'm operating in radians, and that would be the case here. So I'm going to go to mode, come down here, And yes, I'm in radians. So I can just reaffirm that by clicking enter, and I can hit clear. And now I'm going to go ahead and compute this. And the way I'm going to do that is 19 sine parenthesis. Actually, let me try that one more time. 19 sine, okay, pi divided by 6, second pi divided by 6. Now, parenthesis, 10 minus 4.3. Close that parenthesis, close the other parenthesis, plus 74. And there you go. That's my answer. Answer happens to be 76.97. Now, I'm going to assume that I want this to one decimal place. So since this is 5 or higher, I'm going to round up. The 9 will round to 10. I'm going to carry the 1 to the 7 to this digit right here. So that's going to give me 77.0. Once again, if I round up, I'm going to get 10, 0, 1, and we get that. Okay, now what about the next one? Well, the reason why I wanted to do it this way was because you can actually take advantage of your history. Instead of typing all this stuff in again, what you can do is highlight this value up here, hit enter. It's down here where you can work on it. Then what you can do is you can come over the 10. Okay, and what we can do is change the 1 to a 4 and then delete the 0. And that's the equation that we want to compute. Hit enter. That happens to be your answer. That's going to be 71.02. Once again, we want it to one decimal place. This means that we do not need to round up, so this will round to 71.0. And that is all that I have for this particular video. If you have any questions, please feel free to contact me. This is Bob Little, signing